Alright, in this video we'll be going over investigation 9.1.3. So just a quick recap. Know that the A value, the red letter, knows that adjusts the stretch and direction. So again, I can make it narrower, I can make it flatter, I can flip it upside down. So the A value affects how much it stretches, right? If I mess with A, the number in front, I can make it wider or I can make it stretchier. Which parameter represents the vertical shift? That's going to be K. Notice the green letter right here. Notice that if I change that, it will move it up or down. So I can add to move it up, or I can subtract to move it down. And the parameter that affects the horizontal shift, that's going to be H, the blue letter. So here, the blue letter is kind of inverted controls. If I want to move to the right, I'm going to subtract. Right? And if I want to move to the left, I'm going to add. So it kind of works backwards, right? Again, normally when you think of right, you think of positive, but again, we're going to subtract to move right, and then we're going to add to move left, right? So again, for the horizontal shift, it is backwards, right? Right is subtract, and left is add. Right, with that in mind, let's go ahead and sketch a couple of these graphs. So here I want a graph that's shifted +2. Again, +2 actually means I'm moving it left 2. And +2, I'm moving left 2. And I want a vertical shift of up 4. 1, 2, 3, 4. So there we go. And here, the vertex is going to be at -2, 4. So -2, 4. That's my vertex, right? It's when the graph starts to turn back around. Okay. Let's try the next one. Here, +1. +1 actually means I'm moving left 1. Again, opposite, right? +1, I'm actually moving to the left. And I want to shift down 2. So I'm going to go down 2. 1, 2. Here's my graph. And I see that my vertex is at -1, -2. -1, -2. One thing you might notice that -1, -2, 1, 2, we can kind of see these numbers inside of our equation, right? The 2 is right there. -1 is the opposite, but the 1's right there. So that's going to be helpful for something else as we move forward. So just keep that in mind. Some of the numbers we see in the vertex is appearing inside of our equation. Okay. So how can we change a quadratic equation to graphing form? So that's going to be our focus. So here, later on, we're going to have practice problems. And so these are similar to the practice problems that are later on. So here, in order to shift it to the left, I'm actually going to take x, and I'm going to add to it, right? If I add, do you see how it shifts to the left? +1, +2, +3. Right? So if I add, it's going to shift it to the other side, to the left. And now I want to move it up. Right? So now the vertex is in the right spot, but look like it's stretched a little bit more. Do you see how it doesn't quite overlap? So let's start stretching it. Let's try ×2, and it works, right? So anything within an A, k minus h squared plus k, anything written in this format, right? We have something in front, x is being shifted, the height's being shifted. This is called graphing form. And kind of like the name implies, it's because it makes it easier to graph the parabola. All right, let's try another one. Here, if I want to go to the right, again, inverted controls. If I want to move to the right, it's actually going to be subtracting, right? -2, -1, -2, -3, all right? Looks like we're in the right spot now. And now we're going to move it up. 1, 2, 3, 4. Let's do +4. All right, and it looks a little bit too stretched for what we want, so we're going to put a number in front. Let's do ×2, and it worked. Here, what's the vertex? Let's see, the vertex is at 3, 4. And hopefully you guys noticed the 3 right here, the 4 right here. We can kind of see the 3 and 4, the vertex inside of the equation itself. All right, and this one, I want to shift over here. So again, to move it right, I'm going to subtract. Again, inverted controls. Move to the right. Move 1 to the right, 2 to the right, 3 to the right. Again, notice that I have to subtract in order to move it over. And then I'm going to move it down, -4. Right, and I don't have to stretch this one. It one overlaps already. So where's the vertex for this one? It's going to be at 3, -4. Okay. So one thing you should notice is that the vertex can be found inside the equation, right? We see the 3 here, we see the -4 there. Okay. So sometimes the graphing form is called the vertex form because the vertex is found inside of the equation, all right? So here, without graphing it, can we guess where the vertex is going to be? So each of these answers is going to be a point. So let's set up our point. All right. So here I can see that we're shifting down 2, so the vertex is at -2. This one's a little bit tricky. Remember that x is the opposite. So +1 is actually going to be on the left side. It's actually going to be on the left side, 1. Okay. Here, 7 and 2, I know it's shifted up 2. And remember that inside the x is backwards. So +7 means it's on the left side 7. +7 means it's on the left, all right? +7 means it's on the left. And then finally here, I know it's shifted up 4. So 4. And this 5 is telling me -5 means it's on the right side, all right? It's kind of opposite, right? -5 means it's on the right side. So again, everything else works the way we think it should. It's only that the x part, that's going to be backwards, okay? So here, let's go ahead and analyze this problem and see what sort of things we can figure out. So to determine the y-intercept, remember that for the y-intercept, x has to be 0. In order to cross the y-axis, its x position has to be in the middle. So I'm going to copy and paste this. And instead of x here, I'm going to place x with 0. And then from here, let's see, 0 minus 3 is going to be -3 squared minus 4. -3 times -3, that's going to be +9. And then 9 minus 4 is going to be 5. Okay, so our y-intercept is at 0, 5, right? When x is in the 0, y height's 5, 0, 5. All right, determine the x-intercepts. Again, I'm going to make y 0 this time. So let's go ahead and copy and paste. The height has to be at 0 in order for it to cross the x-axis. All right, let's move -4 to the other side by adding 4 to both sides. All right. From here, I can square root both sides. So again, I can square root 4. I can square root 4, square root both sides. And so here is where we have a split. When I square root 4, it can either equal +2 or it can equal -2, right? Because 2 times 2 equals 4, and -2 times -2 equals 4. So when I square root, there are 2 possible answers, a positive and negative answer. And then we still have the x minus 3, right? Notice that when we square root, square and square roots are going to cancel out, which is why we're just left with x minus 3. And from here, we can split our answer. We can either get the positive version or the negative version. All right, +3 on both sides, 5 equals x. And +3 on both sides, 1 equals x. So those are our 2 answers. Okay. So let's go and rewrite this in standard form. In order to write in standard form, we're actually going to multiply this using our area model, x minus 3 squared. So x minus 3 times x minus 3. X times x is x squared. X times -3 is -3x. All right, x times -3 is -3x. And then -3 times -3 is going to be +9. So altogether, we have x squared. -3 minus 3 makes -6. And +9. And don't forget, that's just this part right here. We also have this -4 at the end. All right, 9 minus 4, let's combine those. Let's get 5. And so this is going to be it in standard form, right? Something x squared minus something plus our constant. We can still rewrite this into one other form, which is factored form. Again, you can think of that as the base and height of our area model. So we have x squared minus 6x plus 5. And how did we get 5 here? I could do 5 times 1. But notice that, again, here it's negative, right? So let's go and try -1 and -5, okay? So x times -5 will be -5x. And x times -1 will be -x. And notice that -x and -5x, that's how we get our -6. And then -1 times -5 is how we get 5 in the corner, okay? So this base and height, I can write it as base times height, x minus 1, x minus 5, all right? Base times height. Right? So these are the 3 ways you can write an equation. We have graphing form, we have standard form, and we have the base times height. So which one is the most helpful when we're trying to graph? Is actually going to be graphing form. It's kind of in the name. For this one, -3 is going to move right 3. And then -4 will be down 4. I think I put the wrong answer key. This should be correct, even though it doesn't show you the green check mark. This should be correct, right? Right 3 and then down 4. Okay. So with that, now, the equation doesn't always start off in this formatting in graphing form. Usually it starts off in standard form. So how can I go from this formatting to it looking like this? So again, in the previous problem, we changed this into standard form. What would be the process going backwards? If I start with this part, how can I make it look like something squared minus something? So if I want to get a perfect square, we can use completing the square to change a standard equation into graphing form. So again, completing the square makes something squared, and then it's going to look something like this formatting here. So let's go and take a look at the next example. So here, given this expression, can we write this as a perfect square? So let's see, again, to get a perfect square, notice the 6x, we're splitting it in half. Half goes here, half goes here. So 3x and 3x makes the 6x. And the reason we're splitting it in half is so that we have the same base and height, right? x plus 3 is going to be our base, and x plus 3 is going to be our height. Notice that the rest of the box fits. 3 times 3 is 9. 3 times x is 3x. Everything else fits. So this is the equation x plus 3 squared. So this is our perfect square. Again, I found the same base times height, so I turned it to the perfect square. And now that it looks like this, it's really easy to tell how it's looking, right? Plus 3 means it's moving which way? Again, plus 3, you think the opposite. Plus 3 means I'm on the left 3. And I can tell that easily because I have it in graphing form. So what's one of the benefits of changing it to graphing form? It makes it easier to tell where these go. So here, let's go and try completing the square. If I split this in half again, 3x and 3x, notice that 3 times 3 does not equal 9. So I don't have enough to complete my square. So I need to change. I need to add more tiles. How can I get 9 tiles here? I need to add 8 to both sides. So notice that when I add 8 to both sides, 1 plus 8 equals 9. And now I have my complete box, right? 3 times 3 equals 9. The box now works. And I can put my x's here. X times x is x squared. So now I have it as a perfect square. We have x plus 3 squared. X plus 3, which is now a square. We're not quite done yet. Again, notice this plus 8 here. Again, if I want to solve the quadratic equation, I need to, I want to change the graphing form. I need a minus 8 on both sides. So let's subtract that, put it over here. And now it's in graphing form. And now that it looks like this, it's pretty simple to graph. Again, it's shifting down 8. So 1, 2, 3, 4, 5, 6, 7, 8. It's also shifted to the, again, plus 3 means left 3. 1, 2, 3. Again, inverted controls. All right, let's do a few more. So let's go and rewrite this as a completing the square. So let's see. I can split 2x in half. Minus 2x minus 2x. Okay. Minus 2. But notice that minus 2 does not multiply to positive 3. It should turn into 4, right? So I have 3 tiles here, and I want to make a total of 4. I need to add 1 to both sides to complete my square. So now that negative 2 times negative 2 is 4, I can split up the x's. So we have x minus 2 times x minus 2. So that's going to be x minus 2 squared. And to get rid of the plus 1, we can minus 1 on both sides. And here is our graphing form. And again, the nice thing about this, again, I know it's shifted down 1. And minus 2 actually means it's moving to the right 2. Okay. So let's go ahead and rewrite this one. Let's split 8x in half. So again, to make a square, half of the tiles go here, and the other half go here. Notice that 4 times 4 does not equal 10, so I need a few more tiles. How can I get this to be a perfect square? Let's see, I can add 6 to both sides. 10 plus 6 equals 16, and now it completes the box. 4 times 4 equals 16 now. And now I can split up these x. X minus 4 times x minus 4, which is x minus 4 squared. Okay, I'm not done yet because, again, we need to move the 6 back. So let's subtract 6 on both sides. All right, so, plus 4. Sorry about that. So now this is like this. I can go ahead and shift the parabola. Remember, it's opposite. Plus 4 means it's actually moving left 4. 1, 2, 3, 4. And then minus 6 is moving down 6. 1, 2, 3, 4, 5, 6. All right, and last one. Second to last one. Yeah. So let's go and complete the square here. Minus 10x can be split in half. So I put 5 over here, 5 over here. Okay, notice that again, 5 times 5 equals 25. We actually have too many tiles, so we need to get rid of 2. So minus 2, minus 2. So you have x minus 5 and x minus 5. Right? Negative 5 times negative 5 is 25. X times negative 5 is negative 5x. So everything checks out. So we can write this equation as x minus 5 squared. But again, we still need to deal with this minus 2. So let's go ahead and add 2 to both sides. Right? And so this is what it's going to look like. I'm going to move it up 2, right? Shift 2. And again, backwards minus 5 actually means to the right 5. 2, 3, 4, 5. Okay. Right? I think this is the last one. So let's go and rewrite the equation as a perfect square. Again, I take 12x and split it in half. 6 and 6. Okay. I can do plus 6 over here and plus 6 over here. So notice that 6 times 6 equals not 36. So again, this one's a little bit too big. So we need to get rid of the tiles so that it's a little bit closer. Let's do minus 7. Yeah, minus 7. Now this is a square. And I can change this part to a square. Okay. So let's go ahead and see. We have x minus 7 times x plus 6 squared. Oops, sorry. Okay, and we're not done yet because, again, to get rid of the minus 7, I need to add 7 to both sides. Plus 7 plus 7. Right, and there's our equation. Now let's go ahead and graph this. 7 units up. 1, 2, 3, 4, 5, 6, 7. And then we're going to do plus 6 means actually left 6. 1, 2, 3, 4, 5, 6. Okay. All right, and let's answer the focus question. How can I change a quadratic equation to graphing form? I can use completing the square to change an equation to graphing form. Okay. And so here, let's go ahead and see if we can write the equation for this. If I want the vertex down here, again, originally it's at 0, 0, but I want to shift it down. So let's do minus 5 to shift it down. I have the vertex in the right spot, but again, it's not crossing to the point. So let's go and stretch the parabola. Let's do times 2, a little bit closer, times 4, a little bit closer, times 6, almost, times 7. There we go. So I can shrink the parabola, right, or stretch it out by multiplying by a number, and I shifted it down 5. Okay, last one. I want the vertex right here. So again, let's go ahead and move it to the right 1 by minus 1, and I want to move it up 4. Okay, in order to reach this point, I need to flip the parabola over. So let's do minus, and it looks a little bit wider than it should be. So let's do minus 0.5, and it looks like that one works. Right. So if you still have questions, please let me know.